relays. In today's class, we'll cover the remaining basics of protection coordination of relays. So, in our last class, where we understood that mainly the combination of time and current grading, that is the practical method which is applied in the relays, and those relays are called IDMT relays. And these relays is called inverse definite minimum time relay concept. In this concept, the relay operating time is or T is equal to TMS, time multiplier setting, into K divided by I/IS. I is the fault current and IS is your pickup current in ampere, or I is the current in kiloampere, and here I/IS to the power alpha minus 1. So from this formula I can find the operating time of the relay, where K and alpha are the curve constants. These curve constants can be found out from these inverse curves, inverse definite minimum time relay, or these curves, standard inverse, very inverse, extremely inverse. With the standard inverse, first, second one is your very inverse, and third one is your extreme inverse. So in the x-axis we take I/IS, fault current to pickup current ratio, and the y-axis we take operating time, and the curve will take this. The relay coordination sequence in a typical 33/11 kV substation, see that from downstream to the upstream. In downstream, the delta feeder, that is MCCB, air circuit breaker protection is there. This is again standard type or short delay type. Then the 11 kV feeders, here the relay operates overcurrent and earth fault relay, which is fastest operation, fast to trip here. You see here, this is the 33/11 kV substation is isolated. First is your trips fast. This is the main protection, that is overcurrent and earth fault relay. This trips fast. Then for backup relay, overcurrent and earth fault at 11 kV site. It is at a 30 kV site. This T side, this is at LV side, 11 kV. Then these are the 11. These are the sequence. Then see more. Then 11 kV boss incomer, 11 kV boss incomer. The backup for feeders, time delay added. Then transformer protection, differential type of relay is employed. This differential time of protection is called instantaneous, very instantaneous, and its backup is overcurrent relay with relay. On the 33 side, there is a directional overcurrent and discharge protection. The highest delay backup. Minimum time gap between two relays 0.3 to 0.5 seconds. We have to ensure that the downstream relay clears fault fast. Upstream operates only if failure occurs. Pickup current based on the load current and CT ratio. Typical pickup current is 1.2 to 1.5 times the full load current. Then secondly, key setting for the coordination, time multiplier setting. Adjust relay operating time. The lower the time multiplier setting, the faster is operation. Curve selection, standard curve, whether very inverse or so generally the guideline is for feeders there is a standard inverse curve is referred. For transformer very inverse curve is referred, and for long lines the extremely inverse curve is referred. You must calculate the maximum fault current and minimum fault current also using the system impedance and transformer impedance and source contribution. So TCC curve, these are the TCC curves. TCC curve for MCCB, TCC curve for fuse, TCC for MCCB, and this is for relay. Relay. The coordination is visualized using the log graph. There is TCC curve, current versus time curves. This is the current versus fault current versus time. The goal is the curves should not overlap. These curves should not overlap. Maintain coordination time interval gap. Coordination time interval gaps will be there. Otherwise, there will be malfunction of the power system. This is the example taken for a 11 kV substation. Below the feeder, the pickup current 100 ampere for its incomer 150 and for transformer 200, and time multiplier setting 0.1, 0.2 and 0.4, operating time 0.2 second, 0.4 second and 0.7 second. Gradually it increases time delay. Transformer protection coordination. For transformer protection coordination, the protection employed here they called differential protection, which is instantaneous type of protection, protective device. No coordination needed here. Instant is main protection is the main protection, and backup overcurrent must coordinate with the feeder. There is a backup here. Even HV inverse time overcurrent relay 50-51, LV inverse time overcurrent relay 50-51, and here ground fault protection relay 50N and 51N. For transformer protection, this is a restricted earth fault, 64 REF, book hold, relay, gas pressure 63, thermal protection 4926, and is for surge protection, surge arrestor is there. So it is more sensitive than phase fault. Surge arrestor. Typical pickup should be 10 to 40% of the phase current. This software used for calculations of short circuit calculation and all mathematical analysis. We take this ETAP, DG Silent, Power Factory, and SCAM Power Tools. We should be cautious regarding the common mistakes. No CTI margin. That means there should be a proper coordination time interval, so that it will not proper, then will any needs and stripping. Unnecessary tripping will the system will occur. Wrong CT operation. If the sitting operation is wrongly operated, then the relay will misoperate. We should not ignore the minimum fault current. Your attention should say there is no overlapping for TCC in TCC curves. Earth fault settings should be proper. So when the design of the protection coordination is required for design of the power system, and the practical workflow for that, first is your load calculation, then the short circuit study, then from that we can select the CT ratio. Basing on the CT ratio, we can choose the relay type, IDMT, then set pickup current, select the curve type, which curve, standard curve or inverse curve or very inverse curve, adjust the time multiplied setting, then plotting of the TCC curves. Where we have to verify the coordination time interval should lie between 0.3 to 0.5 seconds. Otherwise, there will be nuisance stripping of the power system. Validate for all the fault conditions. We have to check the fault conditions, whether the conditions are okay or not. So this is a practical workflow guide diagram. Here, power data collection, system data collection, then SLD 3311 kV feeder, SLD, then fault level calculation, then CTP selection, relay selection, whether it is OCR or EFR or distance protection, then pickup setting, then TMS setting, curve selection, coordination check, plot TCC curve, then validate everything. Then the system will be okay and design will be okay. In the coming classes, we'll more thoroughly calculate these stepwise for practical real coordination, real coordination of relays. We'll practically calculate on a specific system having input data. From the input data we can find out what are the circuit studies and all these things in the workflow. So in this class I have only told you the basic idea how to proceed in protection coordination of the relays or protective system for power system design. Thank you.